You're commuting to work on what feels like a roller coaster, soaring over streets, weaving through mountains, crossing rivers, and then suddenly blasting straight through the side of a residential building. This isn't some futuristic fantasy or theme park ride. This is the daily reality for millions of people in Chongqing, China, home to the most extreme metro system ever built. Welcome to a journey through engineering brilliance, where the impossible became possible. I'm your host, and today we're diving deep into how China managed to build a transportation network that defies every convention of urban planning and engineering. When you think of cities, you probably imagine them built on relatively flat terrain, maybe with a few gentle hills scattered around. But Chongqing throws that assumption completely out the window. This Chinese metropolis is built across a range of unusual mountains that slice through the urban landscape like fingers on a giant hand. It's a city of extreme verticality, where the difference between the highest and lowest points spans an incredible 250 meters. To put that in perspective, you could construct a skyscraper in the lowest parts of the city, and its peak still wouldn't reach the elevation of the highest neighborhoods. This topographical chaos is home to 32 million people. That's 4 times the population of New York City, all living in what one Guardian journalist described as a cross between the movie Inception and a game of snakes and ladders. Others have dubbed it the 8D city, though what 8 dimensions would actually look like is anyone's guess. Well, apparently it looks like Chongqing. But how do you move 32 million people through a landscape that seems designed to prevent efficient transportation? A few decades ago, the answer was simple: you didn't. There were no trains in Chongqing. People walked, drove, cycled, took buses, or occasionally rode cable cars. The roads were perpetually clogged with traffic that would make even the most patient commuter lose their mind. At rush hour, single roads would see tens of thousands of frustrated people all trying to get to work simultaneously. One transportation expert declared Chongqing's transport system the second worst in all of China, which is saying something for a country with over 1 billion people. The city desperately needed a metro system to relieve the pressure on those gridlocked roads. But the thought of actually building one seemed almost laughably absurd. Building a metro anywhere is challenging, but in a city like Chongqing, it felt impossible. Yet somehow, against all odds, they managed it. In 2005, the Chongqing Metro opened its doors to the public, and what they created was nothing short of extraordinary. The system now covers 560 kilometers of track, making it longer than the New York subway or the London Underground. It's officially the 6th longest metro system in the world. But length alone isn't what makes this network so incredibly unique. What makes it unique is its absolute defiance of traditional metro design. This system runs on bridges high above the city, hugging the sides of mountains like a scenic railway. Most remarkably, it runs straight through residential apartment buildings. Imagine looking out your 8th floor window to see a metro train rolling past your living room. These aren't specially designed transit buildings. These are regular residential apartments with river views and a metro line casually running through the 8th and 9th floors. The system holds multiple world records that seem almost too incredible to believe. Chongqing is home to both the highest metro station in the world, with a platform nearly 50 meters above ground, and the deepest station in the world, buried more than 100 meters below the surface. The journey to the deepest platform takes 8 full minutes on escalators, and passengers report their ears popping from the pressure change during the descent. Even more remarkably, these 2 record-breaking stations are on the same line, just a couple of stops apart. The bridges connecting this system are engineering marvels in their own right. The Liang-Luku Rail Transit Bridge stretches 1.6 kilometers as the world's longest metro-only suspension bridge. The Kaiyuanba Rail Transit Bridge towers 100 meters above the Jialing River, making it the highest metro-only bridge on Earth. On foggy days, crossing this bridge feels like riding a train through the clouds themselves. Then there's the Kaohsiaman Bridge, holding the record as the world's longest through-arch bridge at 1.7 kilometers, surpassing even Sydney's famous Harbour Bridge. But how did they actually build this seemingly impossible system? The story begins in the 1940s, when various groups first proposed a metro system for Chongqing. Every attempt was abandoned because the project seemed technically unfeasible and prohibitively expensive. While Beijing and Shanghai built their metro systems in the 1970s and 80s, Chongqing remained without rail transit. Everything changed in the late 1980s when a new determined task force was established. This group was serious about making it happen. They spent years traveling abroad, studying metro systems in other countries, and learning everything possible about building railways in challenging vertical environments. One of their most crucial realizations was that conventional railway technology wasn't suitable for Chongqing. Traditional flat tracks, like those used in Beijing, Shanghai, London, or New York, simply wouldn't work in this vertical city. Instead, they embraced an alternative: monorails. This decision was revolutionary. A monorail track is significantly lighter than conventional rail, which means fewer support structures are needed for elevated sections. The task force calculated that a conventional metro would cost over $200 million per kilometer, while a monorail system would cost roughly half that amount. Monorails are also more energy efficient, using about 1/10 the energy of conventional rail stations. They handle tight turns and steep slopes much better than traditional systems, making them perfect for Chongqing's challenging terrain. You might wonder why monorails aren't used everywhere if they're so advantageous. The answer lies in their limitations. Monorails only make sense for elevated systems. For underground railways, they're actually problematic because they require more vertical space than conventional tracks. Traditional rails are low and flat with trains riding on top, while monorail systems use one tall rail that trains straddle on both sides. When you're excavating underground tunnels, the last thing you want is a system that requires taller tunnels, which means more time and money spent digging. For most cities, monorails are a poor choice. But for Chongqing's unique 8D landscape, they were perfect. However, building elevated monorail in Chongqing presented its own challenges. Typically, you'd build support columns first, then use cranes to position each piece of rail. But Chongqing's narrow streets, steep slopes, and dramatic elevation changes made crane access impossible. The task force developed an ingenious solution: a specialist beam transport machine designed specifically for this project. This remarkable device would grip a piece of rail to its underside, crawl along the support columns, and precisely lay the rail into position. It was like watching a mechanical spider spinning a web across the city. In December 2000, these machines were finally put into action. Just 5 years later, the first line opened to the public. Line 2, as it's known, was mostly elevated above city streets, though a few kilometers ran underground. This inaugural line is the one that passes through those apartment buildings, creating one of the most surreal commuting experiences on Earth. The apartment building integration required incredible engineering precision. When the line was being planned, the land was owned by a construction company that hadn't yet built anything but was planning to. Rather than relocate the rail line, the company worked with the Metro Authority to design a building that could safely accommodate a train line running through it. The engineering challenge was immense. How do you prevent vibrations from a moving train from damaging the surrounding building? The solution was brilliant in its simplicity. Engineers installed vertical tubes within the building structure, with monorail pillars positioned at the center of each tube. The tubes were wide enough that even when the pillars vibrated from passing trains, they never touched the sides. For residents, the noise level is surprisingly manageable. The sound of passing trains measures about 60 decibels, roughly equivalent to a running dishwasher. Annoying perhaps, but not unbearable, especially considering the incredible engineering feat happening just outside their windows. After successfully completing the first monorail line, construction teams continued expanding the network. A few years later, they finished a second monorail line that broke even more records. It became both the longest and busiest monorail line in the world, carrying approximately 250 million passengers annually. As the system grew, engineers realized that Chongqing's vertical complexity required a combination of both monorail and conventional rail technologies. Some lines needed to soar high above the city, while others had to tunnel through mountains. This led to the mixed network we see today, with 12 operational lines and 3 more under construction. Building the conventional underground lines presented different but equally daunting challenges. Hongyangan Station, the world's deepest subway station, took 3 years to complete.